So remember, this technique requires that we know the first solution. So can we guess y1? So if we look at it, these need to be opposites. One thing that I can think of when we take the derivative, we get the opposite is sine or cosine. So how about if we guess y1 equals sine of 3x? Then we'll get y1 prime equals 3 cosine of 3x. And then when we find our second derivative, it is minus 9 sine of 3x. So let's check it. This is minus 9 times y. Oh yeah, that works. So we found our first solution. So y1 equals sine of 3x. But our substitution involves a u set, remember? And if you can remember, u equals y2 over y1. You can remember it that way, or you can remember that y2 is u, which is a function, times y1, so they're linearly independent. Okay, so it's from here that I'm going to I need to find my second derivative and plug in my y. We plug in to check to see if it's a solution. So if we go and take the first derivative and the second derivative now, we're doing exactly what we did up there. But we remember we found our y1. So let's plug it in. And then we can take our first derivative and second derivative and then plug it in to our differential equation. So let's take our first derivative. So we have to use the product rule. Product rule again twice. So we take the derivative of this, which will be minus 9. So we're going to plug it into here. So our first term is all of this. I think I'll just kind of copy it. That way you don't make any mistakes. Copy. Plus 9 times y. This is our y. Equals 0. Remember what we said, the two middle terms are going to add. Oh, look at that. That cancels with that too. Even nicer. So now our reduction. And we can call this dw dx. And separate it, because there's only two terms. Might as well bring it to the other side. Doesn't matter which one you bring to the other side. So let's separate this. Dx, dx. We'll get rid of the w. The w. Get rid of the sign. That's it. Now we can integrate. I'm not going to put the opposite value, it's going to go away again. So that 3 plus C1. We integrated. There's our first constant. Again, it could go on either side. Well, I usually like it on the right. You don't need to have a C1 on both sides. It'll just get absorbed. So now power rule, that has to go to the power. The product, same base. This is just a constant. We'll just call that C1. We'll rename it C1 again. A little illegal there, but that's okay. We didn't know what C1 was in the beginning, so well, we know. We can go ahead and, instead of what is W, it is, geez, I forgot, U prime. Here. And then V sine of 3x. And here's where we have to integrate it again to get U. Do it in blue. In terms of dx. So U. Oh, that's sine. And that's one of our trig functions. Remember secant squared, the integral of secant squared is tangent of theta. And this is cosecant, it's cotangent of theta, of cotangent of that angle. If you want to do a whole U sub, we do see whether the 1/3 goes there, it gets absorbed. There might be a negative. It all gets absorbed into our C1, which we yet rename the same thing. Plus, we just integrated. There's my C2. So remember what U is? U, I'm going to just backtrack it this way. It's Y2 over Y1. Y1 was, geez, I forgot. Right here. Sine of 3x. So solving for Y2, it is C 1 cotangent of 3x times I think cotangent is cosine over sine. So we're going to use Abel's formula now to do the same problem. Kind of looks like we have a general solution here, doesn't it? So now the alternate approach. Let's see if you can write it out. It's good practice to stop here and just try writing it out. See if you remember it. y2 equals e to the minus integral of p of x dx all divided by, inside the integral, y1 squared dx for that integral. So what's our formula? Y double prime. What's our p of x equal to? Our p of x is the y, the middle term, which we have none, so it's 0, right? y1 is still sine of 3x. So this is e to the minus 0 plus c, which is really e to the c, which is just a constant. Or you can just call it a constant. This basically goes in the front. So integrating this, it's the same thing. Cotangent of 3x. I can divide by 3, but that'll get absorbed in a constant. And again, this is cosine over sine. C1 cosine of 3x. So interesting enough, remember our y1, we don't really need the constant yet. That's our y2. Could be there or not. Just a specific formula. Sine of 3x. Those are independent. And my general, and there's 2 second order, so my general solution, it's y equals c1 cosine of 3x. Well, I guess technically it's sine of 3x. Of course, that really wouldn't matter. So that's it. So we're going to solve the second order dE, but this one's in terms of t, not x. So let's be careful. So the first solution is given. y1 equals t. So we're going to let y2 equal to u y1. y2 is equal to ut, right? So that's my first one that I'll need to plug in to the dE. y2 prime, product rule. But we want to be careful. T prime is the derivative of t. I told you it's with respect to t, so that's just 1. So y2 prime u times, again, the derivative of t is just 1. Okay, that's 1. Let me do this one first. And that's the winner that we'll use. So again, we'll be plugging these 3 and here, here, and here. Let's do it. Okay, what happens? Anything? Do we get rid of anything? Oh yeah, these 2 cancel. Maybe I should have kept them in the same order, but they're the same term. I'm sorry, there's never a 2 there. That got distributed. I think everything else is fine. In terms of t, easy separation. So now we're ready to integrate. Yeah, that becomes just e to the natural log of t, e to the c1, which is just t, c1, c1t. W is u prime. We integrate again in terms of t. And again, we don't need to divide by 2 plus c2. U is equal to y2 all over y1, which is t. So y2 which again, since we already got this to be our y1, it looks like our y2 is really t squared. That's going to be my general formula. We can check to see if it's independent. Don't forget that. T squared. Which is non-zero as long as t is not equal to 0. So I want to do it with Abel's formula, the alternate approach. On my exam, I usually ask you to do it both ways, by the way. And you should write out the formula first. Well, in this case, we might as well write it with a t. Should have it memorized by now. So we have y1 is equal to t. Oh, what was our formula? It's our p. So be careful. Our p is not minus 3t. So you get in trouble. It's got to be in the right form. So that form assumes. So if you remember, t doesn't equal to 0. That's why we're allowed to divide by it. Okay, so it's minus 3 over t. The minus out there already. All divided by t squared dt. Remember, you have to do the power rule, so that's t to the third. So y1 is t, same as what we got last time. Oh, and when we multiply by t up here, that is a third. We did get the same thing. That's why you do it both ways. That's why you show your steps. So certainly it could be over 2, it doesn't matter. Because when you write, when y1 is t, or y2 is t to the third, if we want to put the half there, we can. Our general solution is y equals c1t plus c2 t to the third. So that divided by 2 gets absorbed. So we don't really need it into that constant.